All right, so starting on our review for the Unit 7 exam here. Number 1, we have a plumber charges a fixed fee of $75 for a service call and $40 per hour for all hours worked on the job. We're going to write a linear model in terms of the cost, C for the hours worked H. So if we're thinking here, that 75 sounds like a fixed fee. So that's like having our B being equal to 75, and then 40 is our slope. So if we're going through here, we want C, and then H represents hours, so we're looking here at choice D. Going on to 2, using this model, find out the total cost for 10 hours of work. So what that's saying is plug in 10 for H, and we'll get a cost of $475. Going on to 3. Roger has 100 aluminum cans to recycle and plans to collect an additional 25 per week. And then we're writing our linear model, right? So here that 25 per week, and it's an additional, so we're adding that on. So that'd be 25W plus 100. So we're looking at choice B. Using this model, how many weeks, so how many W would it take to get 275 cans? So that's 275 is equal to 25W plus 100. We'd subtract 100 from both sides, divide by 25, and we end up with 7. All right. Here, talking about correlation. So which scatter plot represents a positive correlation? So we've discussed correlation, meaning that positive means it's going up from left to right. And correlation just means the points are close together. So the only graph that goes up from left to right would be choice C. Here, which relationship is shown? So let's go through these. We see as the cost of a flight increases, the number of those is going down. So B doesn't make sense. As the cost goes down, the number sold goes down, right? Everyone would want to pay less. Choice C is the cost goes down, the number remains the same. No. There's definitely a relationship because they're close together. So choice A here is the cost goes up, the number of sold goes down. All right. Which of the following is the only correlation that makes sense according to the two items being compared? So for choice A, we have is the amount of copies made goes up, the amount of ink in a printer goes down. Is the cost of a plane ticket goes up, more people go. They're saying there's no correlation between temperature and people outside. And then price of clothing going up and people selling more clothing. So we can see the only one here that makes sense is A. So the more copies you make, the less ink there is. All right, number 8 here. So the scatter plot below shows the average yearly consumption of bottled water per person starting in 1990. And we're trying to make a prediction about 1997. So if I'm looking here, these are 1997. So if I go up, I'm looking somewhere on this point, because it's not saying use the point, they're saying use the trend line. So here's our trend line, we're at about 16. And then it's interpolation because we're using the graph. So just like we talked about back in Unit 5, extrapolation means we're plugging into some type of equation, it's not on the graph. This one's interpolation because again, it's on the graph. Number 9 here, if a high school principal wants to predict the number of students who will drop out of high school or drop out of school so he can get funding for support services. The principal determined this equation since the year 2004. And Y is our number of students that will drop out, so X is the years. And we're looking at how many students will drop out in 2015. So first we need to figure out what it is we're plugging in. If we plug in 2015 into this equation, we're going to get a huge number, which won't make sense. So to figure out the years between 2004 to 2015, we'd subtract, right? So 2015 minus 2004, that gives me X is equal to 11 years. So when I plug in 11, that would be negative 110 plus 216. So I would get 106. Now, we didn't have a graph for this, so this is extrapolation, right? Because it's off the table. We're predicting into the future. So we would want choice C. All right, moving on down, we have a table with some points plotted. We want the equation of the trend line. So they tell us which 2 points to use. So here I have x1, y1, x2, y2. So I'm going to find my slope. So I'm going to use my y1 minus 224 over 150 minus 1100. Open up a calculator for this one. So I can find my calculator. There we go. Oops. Get rid of it. All right. Smaller. Okay, so we have 110. So we get 0.12. And as we see our choices, they're all written as decimals, so no fractions needed. So let's just leave it as 0.12. All right, so I know it's definitely not C or D. Now I need to find that intercept, right? So we talked about a variety of ways of doing this, using plugging in, solving for B, using point slope. So I'm just going to go ahead and solve for B. So if I plug in 110 for my Y, 0.12 for my M, the X would be 150, and then solving for B. So I got to do 0.12 times 150. I get 18. I subtract that, so 110 minus 18. That gives me 92. So I got 92 is equal to B. So my equation here would be choice A. And then how far did you fly if your plane ticket cost $4.75? So if we think here, our Y variable represents the cost of the plane ticket. So for $4.75, well, sadly that's not on my table. So we need to go ahead and plug in. So if I think about that, I have $4.75 as my cost. It's equal to 0.12. X is my distance here. And then plus 92. So a little bit of solving here. We'd subtract first. I'm going to do 475, and I'm going to subtract 92. Then I need to divide that, so that 383 is equal to 0.12x. So if I divide it by 0.12, I get my answer. And as we can see, that would be choice C. All right, moving on. So we're given an equation. And it says the points, 125, 163, and 8700 are on the trend line. So 125 and 163. So 125, 163, no way, right? The trend line saying it's well above 200, right? Or at least noticeably above 200. So that one's definitely false. So we're just saying, are these points on the trend line? Because they're points from the data, but they're not necessarily exactly on the trend line. This scatter plot represents a positive correlation. Well, correlation just means they're close together. Positive would mean we're going up from left to right. This one I could see is going down, so that's also false. It is reasonable to predict that if there's 125 negative reviews, the number of zones will be close to 200,000. So these are in thousands, right? So if I'm looking at 125, yeah, that's definitely reasonable, right? Because here would be on the trend line for 125. That's pretty close to 200, so yes, that'd be reasonable. I'm trying to get left here. Just trying to keep it fairly short for you guys, as always. Okay. The cost of Sarah's daycare is a $35 registration fee and $190 per week for her baby. Independent and dependent. So here we see that it's how many weeks, right? So this would be independent is the amount of time, so our weeks, and this would be the cost. So we want C, and we said it's a 35 fee plus 190 per week W, and then that fee. And find the total for 8. So we would just plug in 8. So let's go ahead and do 190 times 8 plus 35. So we got 1,555. That would be the cost for those 8 weeks. Here it's saying how much she paid. So we'd have 3455 is equal to 190W plus 35. So to solve this, first thing we do is subtract 35 from each side. So let's go ahead and clear. So minus that 35. Then we're going to go ahead and divide by 190. I get 18. So we got 18 weeks. All right, let's check out this page here. So key idea here, similar to all the practice we've done, we got to see what we're given and find the best method. So if when Matt went golfing, it cost $75 per game, plus a one-time fee to rent the clubs. But we're not told what that is. We're saying we played 2 games and it was $166.50. So first thing we got ourselves a slope here at 75. We don't know what B is, but we do have an example, right? So we're given a 2, 166.50. Now, if we think back, this was a perfect scenario to use point slope. So here we're saying we're using C is the cost and G the number of games. So I'm just going to call this my G and my C, right? Or you can use X and Y, either way is fine. So this would still be X and this would still be Y, right? So if we think about that point slope, we start plugging in, right? So I got Y minus 166.50. I'm just going to zoom in a bit here. Go ahead and distribute here. And then adding over that negative 166.5 to both sides. There. So that's our equation. Again, we're just going to substitute that C and G for the Y and X, right? So I got C is equal to 75 times the number of games plus 1650. And then we're trying to figure out the cost of clubs. So that's that one-time fee. So that's represented by B here in this equation. So the cost of clubs is just 1650. So again, knowing that vocab, that one-time fee is representative of B in a linear equation. Okay, monthly rent for an 800 square foot apartment is 500. So we see an example. Let's go ahead and list it out. For a 1600 square foot, it's 700. So we see another example. We list it out. Now, right off the bat here, we see we need to make an equation. We need to do some prediction with it. Now, I don't have a slope. So first step, let's find it. So I'm going to go ahead and plug in to find slope here. Oh, it should be 16 there. Oops, wrong button. And we get 0.25. So we'll go ahead and leave that as a decimal, or you can convert it to 1/4. Either way is fine. All right. Now, again, we talked about a variety of ways here, so I'm just going to go with kind of our, I like that point slope. The point slope is kind of just quick and easy. So I'm going to go ahead and use this point and my slope here. So I have Y minus 500. All right, so I distribute. And I multiply 0.25 times 800 gives me negative 200. Adding that over to both sides, we get our equation. Now, so our equation here, they said they want C as the cost and F is the number of square feet. So we're going to have C is equal to 0.25 times F plus 300. Now, To figure out the cost for running a 2,000 square foot, that means we're going to plug 2,000 into here. So for this one, I would have 0.25 times 2,000 plus 300. So 0.25 times 2,000 would be 500 plus 300 gives me $800. All right, last two here. Okay, John is on a diet to lose some weight. He is losing weight at a rate of 1.5 pounds per week. So I see the word per. That means I got myself a slope, right? And if I'm losing weight, that implies it's negative. So I have M here is negative 1.5. After 8 weeks, he's at 245. So that's an example. So I'm going to go ahead and throw that down as an ordered pair. Pretty quickly here, we should see that we have a point slope setup, right? So let's go ahead and write our equation. And if we distribute on the right side there, what's it going to be? 8, so 12. And then if we go ahead and add over that 245 to both sides, we got our equation. So writing out the equation first, we wanted T for the total weight and W for the number of weeks. So we have T is equal to negative 1.5 W plus 257. So that starting weight was 257. And it says how many weeks till he hits his target weight of 182. So we're solving for W. So for the number of weeks here, we'd plug in 182 for T, that total weight. We'd subtract 257 first. So let's go ahead and solve. So I'd take that 182 and subtract, oops, wrong button again, 257. And then I want to divide that by that negative 1.5. And we'll find out it's going to take 50 weeks. All right, last question for the Unit 7. Oh, I lied. There's one more page. Yep, definitely another page. But let's go ahead and get this one done first. Okay, so reading through this, we could rapidly see we got a 2 example problem, so a 2-point problem. So we got 50, 75, and then we have 300, 250. So finding our slope first. So if we go ahead and plug in, so we got 0.7. So we did 75 minus 250 divided by 50 minus 300. So we got M is 0.7. All right, going into our point slope approach, I'm just going to use the first point here along with my slope. And again, it doesn't matter which point we use. I just tend to always pick the first one because it's first. So if we distribute, and then 0.7 times 50, so I have 35, so minus 35. Add 75 to both sides, and we'll get plus 40. So our equation here, we want C, 0.7, they used I, and then plus 40. And then the price we're looking at here is for 350 invitations. So I would just plug that in for X. So what that gives me is 0.7, 350, yep. So times 350, and then plus 40. So 285. So our price would be $285. All right, now we're on our last page. Marie leaves for work, but she realizes she left her briefcase at home. She returned home to get her briefcase before leaving for work. She stopped to get coffee before continuing her drive to work. And remember, velocity is our rate of change, or slope. Let me tell you what the y values here for D and E. We're at 6. Okay. So what was the velocity Marie traveled when she returned home to get her briefcase? So if we think about our path, she left for work, forgot it, returned home, right? So we're looking when she returned home. So that's from B to C. So that represents this portion of our graph. So our points here, for B, it would be at 5, 5. And for C, it would be at 10, 5. So we find the slope. For that, I would subtract my y. So I have, and there, so point C is at 10, 0, not 10, 5. All right, so when I subtract my y's, I'd have 5 minus 0. On the bottom, 5 minus 10 for my x's. So that gives me 5 over negative 5. So our slope there, our velocity is at -1. And then we want the units, right? So it's minutes and then miles. So it'd be mile per second. Oh, I lied, minute. So miles, I'll just write these words out so it's easier to understand. Miles per minute. All right. And our last question here. What was the velocity Marie traveled in miles per minute after she left home the second time to get coffee? So here we were driving to get coffee before we went to work. So we're looking at from C to D. So for C, we already said the coordinate was 10, 0. D, it tells us it's at 6, so it's at 25, 6. So finding that velocity, we would do subtracting our y's, so 0 minus 6 over 10 minus 25. We'd get 0.4. So I would just do 0.4. And we're good to go. So that is the conclusion of your Unit 7 review. At this point, again, make sure we've asked our questions, we're ready to go, and we're ready to ace this exam.